Today we discuss the topic logarithmic test. If in limit we have relation between e and x like 1 by ex, e by x, x by e, then I advise to use logarithmic test over there. What is the statement of logarithmic test? See, if series un be any positive term series and limit n tends to infinity, log of un upon un plus 1 equals to L. When e involves in this limit, we know log of e is 1. Log m by log n is log m minus log n. Log m raised to power n is n log m. Log of m into n is log m plus log n. So to remove e, we have to take log. See here, if limit n tends to infinity, log of un upon un plus 1 is L, then series un is convergent if L greater than 1 and divergent if L less than 1. Note that the test is applied after the failure of ratio test. We have already discussed ratio test. When ratio test fail, I advise to use Gauss test. But if in limit e term occur, I advise to use log test there. We have to use log test there after the failure of ratio test. And generally, when in ratio test, un upon un plus 1 involves e. Exponential term की. Here is exponential. Or if in limit there is relationship between e and x like e by x, 1 by ex, x by e, then we can apply log test. Like if we have discussed previously Gauss test, and we have relation like x less than 1 by 3. See here is relation between x and 3. If instead of 3 we have x less than 1 by e over there, then instead of using Gauss test, I advise you to use log test if there is relation between x and e. If there will be e, then we will apply log test. See some important examples based on log test. Example, discuss the convergence of the series x plus 2 square x square upon 2 factorial 3 cube x cube upon 3 factorial 4 raised to power 4 x raised to power 4 upon 4 factorial plus and so on till infinity. Now summation un series is given. Our first step is to find un, and on account of symmetry we have to make nth term un. See, in first term we have x, in second term we have 2 and x raised to power 2, in third term we have 3, like 3 cube x cube 3 factorial. So in un, on account of symmetry, we will have n raised to power n, x raised to power n, and n factorial. See how. You can check. You have to check whether un term is correct or incorrect. How? Put x equals to 1. You will get u1. This is my u1, this is u2, this is u3, this is u4, and this is un. Put n equals to 1 over here. What we will get? u1. Put n equals to 2 over here. What we will get? u2. Put n equals to 3 over here. What you will get? u3. Put n equals to 4 over here. What you will get? u4. So our un term is correct. Now next step is to find un plus 1. Replace n by n plus 1. What you will get? Simply replace n by n plus 1. Simply replace n by n plus 1. Now next step is cancel terms as much as possible. And then by taking higher powers of n common, expanding factorial and splitting powers, we have to simplify it. See how. un upon un plus 1 equals to n raised to power n, x raised to power n upon. This will get reciprocal. N plus 1 factorial upon n plus 1 raised to power n plus 1 into x raised to power n plus 1. After finding un upon un plus 1, we have to cancel terms as much as possible, and then by taking higher powers of n common, we can expand factorial and splitting powers so that we can cancel terms as much as possible. See how. This is same. N plus 1 factorial can be written as n plus 1 into n factorial. Here you can take higher power of n common. Splitting power. We can cancel this n factorial. Now we can take n common from here. We will get splitting power. Again splitting power. This will cancel out with this will cancel out with this will cancel out with this. Simplify as much as possible, and then we have to take limit. Suppose this is equation number 1. Now take limit. We know one result. This is E. Sorry, here it is X. Here it is X. When we take a limit, this will become E into X. Now we apply ratio test. Series UN is convergent if 1 by EX greater than 1. That is, if X less than 1 by E. And divergent if 1 by EX less than 1. That is, if X greater than 1 by E. When X equals to 1 by E, ratio test fails. Now, E involved in limit, there is presence of E, so we have to apply log test over here. Now we apply log test. Put X equals to 1 by E in 1. What we will get? This will get reciprocal E upon taking log on both sides to simplify E. To finish E, we have to take log on both sides. Log M over N, log M minus log N. Log M minus log of this. Now log M to the power N. It is power comes downward before the bracket and power comes before the log. Because we have used log formula. Now, right, you know one important formula. This is expansion of log of 1 plus x. So we use this expansion to simplify it. What we will get? Open the bracket. N will one N will cancel from each term. 1 L N and sign will interchange. 1 will cancel out with 1. For applying log test, we have to multiply N on both sides. We will get again N will get cancelled out from each term. Now take limit and tends to infinity. One over infinity 0, 1 over infinity 0. We are left only with term 1 by 2, which is less than 1. So limit of log test comes out to be less than 1. Therefore, series UN is divergent by log test. Now write down summary of the result. Therefore, series U1 is convergent for x less than 1 by e and divergent for x greater than equals to 1 by e. At end, must write summary of the result. See one more important example based on log test. See one more example. Very, very important question. Discuss for what value of x does the series this series is convergent. We have to check for what value of x does the series convergent. See solution. Given series is here u1 term is given or here for u n plus 1 replace n by n plus 1. When you replace n plus 1, 2 into n plus 1, it will become 2n plus 2. Replace n with n plus 1, 2 into n plus 1, 2n plus 2. Now you have to divide it un by un plus 1. What you will get? Cancel out terms as much as possible. Expand this factorial. Diminish it by 1. Again diminish it by 1. We need 2n factorial as it will get cancelled out with this. Now expand this. This will get reciprocal. This is over. We have to reciprocate it. Splitting the powers. This will cancel out with this. This will cancel out with it. And it will cancel out with it. Now you have to take higher power of n common. What we are left with? And Next step is to take limit. Before taking limit, take higher power of n common. One n will cancel out. 2 into 2, 4. See, 2 into 2, 4. See, one term will cancel out. So we are left with that factor. One power cancelled out, we are left with one factor. Next step is to take limit. As this will become 0, 1 plus 0, 1. This will become 0, 0 plus 1 is 1. Now we apply ratio test. UN series UN is convergent if what is condition? Limit greater than 1. That is if x square less than 4. Keep x square as x square. And divergent if 4 by x square less than 1. That is if x square greater than 4. When x square equals to 4, what will happen? Ratio test fails. Ratio test fails. Don't use comparison test. Go for Gauss test. Go for Gauss test. We have to apply binomial. For Gauss test, we have to apply binomial. Apply binomial. Open the bracket. First of all, multiply this one with this. One with this, one with this. Then this with this. When you multiply this with it is adjusted in order of n square. It is adjusted over here. Don't write n square terms. Take LCM. What is lambda over here? Which is less than 1. Therefore, by Gauss test, series UN is convergent for and divergent for See results of binomial theorem. Alternate positive negative. These are important results of